Multibus is a computer bus standard used in industrial systems. It was developed by Intel Corporation and was adopted as the IEEE 796 bus. The multi-bus specification was important because it was a robust, well-thought-out industry standard with a relatively large form factor, so complex devices could be designed on it. Because it was a well-defined and well-documented industry standard, it allowed a multi-bus-compatible industry to grow around it, with many companies making card cages and enclosures for it. Many others made CPU, memory, and other peripheral boards. In 1982 there were over 100 multibus board and systems manufacturers. This allowed complex systems to be built from commercial off-the-shelf hardware, and also allowed companies to innovate by designing a proprietary multibus board and then integrating it with other vendors' hardware to create a system. A good example of this was Sun Microsystems with the Sun 1 and Sun 2 workstations. Sun built custom-designed CPU, memory, SCSR, and video display boards, and then added 3-COM Ethernet networking boards, Xylogix SMD disk controllers, cheap Rico tape master 1/2-inch tape controllers, Sky floating point processor, and Systec 16-port terminal interfaces in order to configure the system as a workstation or a file server. Other workstation vendors who used multi-bus-based designs included HP, Apollo, and Silicon Graphics Aries. The Intel Multibus-I AMP2 product line was purchased from Intel by Radisys Corporation, which in 2002 was then purchased by U.S. Technologies, Inc. U.S. Technologies is the worldwide, exclusive, authorized and licensed source of Intel, Radisys Multibus-I and 2 boards, modules, cages, accessories, test sets and backplanes. Multibus architecture. Multibus is an asynchronous bus that accommodates devices with various transfer rates while maintaining maximum throughput. It had 20 address lines so it could address up to 1 megabit of multibus memory and 1 megabit of I/O locations. Most multibus I/O devices only decoded the first 64 kilobits of address space. Multibus supported multi-master functionality that allowed it to share the multibus with multiple processes and other DMA devices. The standard multibus form factor was a 12-inch wide, 6.75-inch deep circuit board with 2 ejection levers on the front edge. The board had 2 buses. The wider P1 bus, which pin assignment was defined by the multi-bus specification. A second smaller P2 bus was also defined as a private bus. Multibus standards. Multibus includes the following buses. Multibus system bus adopted as IEEE 796. ISBX adopted as IEEE 959. ILBX local bus extension. Multi-channel I/O bus versions. Multibus-I, IEEE 796 microcomputer system bus, first released by Intel in 1974. The cards did not use front panels, and they used card edge fingers as the connectors. Companies like Northwest Technical still provide end-of-life products for Multibus-I. This bus is obsolete. IEC 796-1-1990 microprocessor system bus 8-bit and 16-bit data. Part 1. Functional description with electrical and timing specifications. IEC 796-2-1990 microprocessor system bus 8-bit and 16-bit data. Part 2. Mechanical and pin descriptions for the system bus configuration with edge connectors. IEC 796-3-1990 microprocessor system bus I, 8-bit and 16-bit data. Part 3. Mechanical and pin descriptions for the Eurocard configuration configuration with pin and socket connectors. Multibus-2, IEEE-1296 32-bit 10 MHz bus at 40 MB per second. Card sizes are 3U by 220 mm and 6U by 220 mm. These cards are larger than the VME Euro card sizes, which are 3U, 6U by 160 mm. It uses TTL gates for drivers and the backplane connectors at DIN 41612 Type-C. Multibus-2 is not yet considered obsolete, but considered mature. However, it is not recommended for new designs. IEEE STD1296 High-Performance Synchronous 32-bit bus. Multibus-2, released in 1987 and 1994. Also as ISO IEC 10861. ISO IEC 10861-1994 Information Technology, Microprocessor Systems, High-Performance Synchronous 32-bit bus. Multibus-2, Historical Uses. Multibus-2 hardware running the IRMX operating system is used in the majority of the core automatic train supervision subsystems on CLSCS, the London Underground Central Line Signals Control System. This was supplied by Westinghouse Rail Systems and commissioned from the mid-1990s. The Central Line is an automatic train operation line. The automatic train supervision elements use a mixture of IRMX on Multibus and Solaris on Spark computers. 16 Multibus-based local site computers are distributed along the line together with 6 central Multibus-based subsystems in the control center. Real-time control and communications functions are provided by the Multibus-based processes, and some workstations provide database functions and the operator consoles in the control room. All subsystem computers are dual redundant. The safety-critical automatic train protection component is provided by trackside and train-borne equipment that does not use Multibus. The system was still in full operation as of 2011. In the control center, Westinghouse also provided a cut-down mimic of the system for staff training and software test purposes, using much of the same hardware and software as the full ATS system, but connected to a computer to simulate train movements and signaling behavior. Oslo Metro or Oslo Tunnelbane uses a similar, although less complex Westinghouse-supplied Multibus hardware control system through the Central Common Tunnel of Fellstunnel and tracks, but was expected to be decommissioned in 2011.